Hi everybody, I'm Professor Rad, and today we're going to compare and contrast the 4 different measures of center that we have been looking at. So, before we begin, I do want to start out with a definition because this heading here says resistance to outliers. So, what does that mean? So, a data value that is significantly different from the rest of the data is called an outlier. It lies outside the rest of the data. So that's where it gets this name, outlier. If a value of a measure doesn't change in any significant way, whether or not you include the outlier in your analysis, then we say that measure is resistant to outliers. So for example, maybe you want to see how far somebody can run in a minute. And so you have 15 people run, and 14 of those people are just like, typical person. But that 15th person is a trained athlete. So you do on your marks, get set, go, and the athlete way outpaces the other 14. So if you wanted to know, well, what's the average speed of a runner? You want to ask that question, well, should I include that athlete or not? If I'm looking at just like a typical person, then that athlete is going to really throw off the data from what these typical people are running. So that athlete would be the outlier because they would be significantly different from everyone else. And you would want to make that decision, should I include that data value in my data set or not? If you want that athlete to have an impact because you're thinking, well, athletes are people too, right? Like, so if we're looking for how fast can a human being run, then yeah, I want to include the really fast people as well as, people who don't go running for, a hobby or a career. So in that case, maybe you want a measure that is resistant to outliers, is not resistant to outliers, because you want that outlier to have an impact on your measure. But if you're like, well, I don't want that athlete to have an impact on my measure of center because they're kind of the exception, not the norm, then you would want a measure that is resistant to outliers. So we're going to explore some different measures of center and see if they have an impact, whether or not outliers included. So for this example, we're going to look at 7 quiz grades for Charlie. So Charlie's got 7 quiz grades. And if I look at these, there's one that jumps out at me. Poor Charlie didn't do so great on quiz 1. His others were okay, right? He's got a 60, a couple 70s, and a few 80s. So if I want to say, what is Charlie's quiz average? I could be looking for a mean, a median, a mid-range, or mode. So what I'd like you to do is to pause the video here and practice each of those measures of center. So find the mean, median, mid-range, and mode for Charlie's quiz grades here. And once you've done that, you can unpause the video and I'll have my answers here and we can compare. Okay, so let's compare our answers and see how we did. So for the mean, I added all of these numbers together, and when I did that, I got 458. And since there were 7 quizzes, I divided by 7, got this gnarly number. I'm rounding to the nearest whole number, so that's the ones place. So that rounded to 65. For the median, the quizzes are in order based on the order that Charlie took them. So I had to put them in order from smallest to largest first. And after I did that, the number that was in the middle was 75. So for the median, I got 75. For the mid-range, you add the biggest and smallest and then divide by 2. So the biggest number was 88 and the smallest was 0. So after I divided by 2, I got 44. And then for the mode, 81 repeated twice, so we have an 81. So if we're assuming that like 90s are A's, 80s are B's, 70s are C's, and so on, if we use the mean, Charlie got a 65. If we use the median, he got a 75, so he had a C. So mean, he has a D. Median, he has a C. The mid-range, he failed because it's a 44. And the mode is in the 80s, so he has a B. So yeah, depending on the measure of center I'm using, Charlie could either be doing pretty well in the class or pretty miserably, right? So the measure of center you choose to use has an impact. Now, we're trying to see how much that outlier of 0, right? He had a quiz grade of 0 here. We want to see how much that impacted his grade. So suppose Charlie missed quiz 1 because he registered late for the class. And so the teacher's like, well, it doesn't make sense for me to count that against you. So we're going to go through this process and find each of these 4 measures of center again, but this time don't include 0. Basically X this part out and repeat. So now just use these 6 values to find the mean, the median, the mid-range, and the mode. And as before, you can pause the video here to work through it, and then you can unpause and we'll compare our answers. Okie doke. So here's what I got this time. So when I added all 6 numbers together, I still got 458. And this time, since there were only 6 numbers, I'm going to divide by 6. And that gave me about 76. For the median, it was nice because I had already put them in order here. I just dropped that 0 since we're not counting that. And so this time when I got to the middle, there were 2 values in the center. And so I added and divided and I found 78. For the mid-range, I added the maximum with that new minimum of 61 and divided by 2. That gave me 74.5, which would round to 75. And then for the mode, 81 still repeated twice, so that's going to be the mode. So the first time we found these values, the values were kind of all over the place. But now notice when we remove that outlier, these values are all much closer to each other now. In fact, we've got 3 C's, and this is a pretty low B. So all of these grades now are more in harmony, I would say, with each other. So let's see which measures of center changed the most and which ones didn't change too much. So if I look at the mean, he had a 65 when we included the outlier and a 76 when we didn't. So when we include that outlier, that has a big impact on the mean. That outlier, that quiz grade of a 0, would have dropped his grade by more than 10 points. That's huge. For the median, when we include that 0, he had a 75. And when we dropped it, he had a 78. So the median changed, but not by too much. And you can kind of see all that does when we look at our data set in order. By dropping that lowest value, it takes what we circled and just loops in the next guy. So it just scooted it over just a little bit. So the median, if we drop the outlier, it helped, but it's not going to have a big impact. The mid-range, drastic. Including that 0, we had 44. Not including that 0, we have 75. And let's see if it makes sense for the mid-range to be so hugely impacted by outliers. So when we think about the formula for mid-range, it takes the extreme values, it takes the maximum and the minimum, adds and divides. So it's based only on the extremes. And outliers are extreme values. They're really big or really small compared to the rest of the data set. So it makes sense that the mid-range would be most heavily impacted because it's based off of the ends of the data set. And then the mode didn't change at all. So the mode might change if there was a tie or the mode was only happening one more time than another, then you could like drop from a single mode into 2 modes. So you might have a slight change with the mode. I guess if the mode was an outlier, that might have an impact as well. But for the most part, the mode generally is going to stay pretty consistent. So those values that changed a bit when we took out the outlier or when we included it, those are not resistant to outliers because they can't resist the outlier. They're drawn towards it, so they are impacted by it. Whereas the values that didn't change so much, like the median or the mode, those are resistant to outliers because the outliers didn't have too much of an impact. So just kind of to summarize that, which measures of center appear to be most resistant, meaning they didn't change very much? Those would be the median and the mode. And least resistant, in other words, the ones that changed a lot, were the mean and the mid-range. So let's wrap up our conversation about measures of center with a few summary remarks, just to kind of pull it all together. So first, although the word average is generally used to mean the mean, right? So kind of in our common conversation, people usually infer the average to be add them up and divide by however many there are. In a statistics class, it could actually mean any of the measures of center we discussed. So we're going to try to avoid using the word average so that we, don't confuse things. And you'll notice sometimes you'll be asked, find an average for this data set, in which case you can find the measure of center that best suits what you're looking for. Now, the mean and the mid-range are not resistant to outliers. So if you want extreme values to have an impact on your measure of center, then you would use the mean or the mid-range. So for example, if I want that athlete to contribute to that average, then these would be good measures of center to use. But if I don't want outliers to contribute, then I'm going to look for the median or the mode. So if you think an outlier might be an error in your data set, or you don't want to include, the extremes, then you can go ahead and use either the median or the mode, and they will resist that outlier much better. If you're trying to find a quick result, so you're just kind of like, looking around a room and you're like making an estimate, you want something real quick, then the mode and the mid-range are good values to use because the mode, you just kind of look around and see what's most common. And the mid-range only deals with the two extremes, the highest and lowest. So once you identify those, it's a pretty easy formula. And lastly, out of these 4 measures of center that we've discussed, only the mode can be used with qualitative as well as quantitative data. So qualitative in this case just means words, and quantitative means numbers. So you can use the mode with both numbers and words. Remember, like I said, hair color or, what's the most popular state amongst a group of people that you're looking at. I don't know, something along those lines. So you can use the mode to summarize or find an average of word type data as well as numbers. So that's going to wrap it up for our conversation about measures of center. In the next video, we're now going to start moving into like a measure of position. In other words, okay, I know what the average might be, but how do I compare to other values in a data set? So I'm looking forward to seeing you then. Have a fabulous day.